Oh man, I know that I got a lot of people waiting for an update on this thing here, but I just have not had time to get to it. About the only thing that I've had an opportunity to do is have this flange made. I'm going to get to that soon, I promise. I've actually had to spend a lot of the last couple of weeks. I've been trying to clean my shop. Doesn't really look like it because I have that project. I've been scavenging fans and stuff out of these power supplies so I could throw the power supplies in my scrap metal. But I have tried. Anyway, I wanted to show just a little change that I've made on the power board here. And anybody who's followed me for very long knows I've had some issues with these things. These Photech solid state relays. And man, I expected with this channel should have ran so much cooler, but they just burn up so fast. And I've had a lot of wind lately. As soon as they got hit with all that amperage that the Healy would throw out, they just popped. So the last time I showed a picture of this, it was all nice and neat with only heavy cables going up to the inputs on the inverters. And now I've got all of this spaghetti again. The spaghetti just keeps coming back. It just keeps coming back into my life. But this seems to be working better. These are, they're not any cheap. They're about the same cost as the Photech relays. But I've got these, instead of dealing with one of the high amperage circuits like the battery power going in, or even the AC power going out, I've got these wired up to the power switches on the bottoms. Ew. Oh, wait a minute. Hey, I know what I can do. Nope, that one doesn't have a power switch anymore. Here we go. This one. Alright, so power switch over here. I just spliced into one side of the power switch. Now, it's DC power to this, so you have to make sure you have a DC relay if you do that. And one of the things that I have noticed is if the turbines spool up really fast, there's a little bit of a delay before the inverters catch on. And whenever that happens, it hits the system with like 70, 75 volts. With my turbine, with the Healy, I imagine it's going to be about like that once I get the i2000 hooked up. But it does work a lot better this way. All of these relays, they are ambient temperature. The whole idea of having my fan there is now completely pointless. It serves no purpose. I'm going to try to find a way to integrate it to where I can get... I'm going to make like little channels that will go up from here to the... or tubes that will go up from the vent on the inverters to my channel. Because these things, they are still getting pretty warm. Like right now, like the whole system's making 1100 watts, sometimes getting up there to around 1500 watts, which means, 250 to 300, maybe 400 on each of these. And they're still getting pretty warm. It's actually kind of calmer now, but 95 degrees on that one. That one's rocking around 100 degrees. Nah, I wonder why that one's the hottest. I mean, it's not like it's unpleasant to touch, so I know it's not getting so hot on the inside as to damage anything, but the fans, they don't seem to run when I think they ought to be running. So I want to get I've been trying to explore ways of adding a fan to those things. I've actually printed a little manifold. Let's see if I can get that to stand up there. I got this little manifold that will let me fit a 70 or 65 or 70 millimeter fan, whatever. That will draft through that hole, help kind of force air through. I don't know how well this is going to work. I don't know if that's even worth doing. I've also contemplated taking the cases off and cutting a 2.5 inch hole back here and mounting the fans to the outside right here and drawing through. I mean, it's going to draw air from underneath the board, which is not going to be super helpful, but surely it will pull from, up top as well. They got to have some more airflow than what they've got. This little fan, the only thing that it draws air off of is this heat sink, these heat sinks on the side over here. But these diodes, not diodes, MOSFETs on this side, they get crazy hot and they don't cool. It doesn't draft anything through. So I'm still struggling with cooling issues. I want to find a way to make it to where these things last longer than they have been. I'm also trying to put together a budget. I want to buy a couple of like Enphase micro inverters or something, and see if I can find a way to make them work with this system. I don't know. So we're still playing with it. This is the current configuration. It does seem to be working pretty well. It actually shows me, this is a pretty good way to show how efficient these things are. It's like I reset all of these about 20 minutes ago, and maybe 30 minutes ago exactly. And since I've made right around 1 kilowatt hour between only the Healy and the washer turbine are running. Those are the only two running right now. And they've made just a little bit over 1 kilowatt hour. And on the input side, I have made about 840 watt hours. So 1 kilowatt hour, 840 watt hours. I'm going to be generous and say 850 because I reset these first, and then after a minute I reset those two. They reset differently and it took me a second to figure it out. So 850, so 85% efficiency. I'm producing so much power, 85% of it is actually making it back to the grid. The rest of it is heat being dissipated from my relays, from my inverters, possibly some undersized wiring and batteries that are less than ideal. But still, 85% of total power produced, I feel like that's still pretty decent for how much is invested here. Anyway, I'm rambling a lot. I meant for this to be a really quick video and it's already 9 minutes long, so thanks for watching, guys. Stay tuned. I promise I will have a video on this in the next couple of days. I'm going to do the same bench test that I normally do, and I'm going to do the assembly, and I'm probably going to get the i1500 in here just to compare the two. So stay tuned for that. That will be here in a couple of days. And guys, have a wonderful, wonderful evening. Stay safe, stay warm, stay comfortable. Thanks for watching.